So we have 3 things we're going to go over today, and we had plenty of time to get through them all this morning. Interpreting average rate of change, simplifying the difference quotient, and solving systems of equations. So the reason I want to do interpreting average rate of change is you're going to be interpreting instantaneous rate of change. So this almost the same thing. Simplifying the difference quotient, because we use that when we're calculating the limit definition of the derivative, and solving systems of equations, because there was a WebAssign question this past week that required you to be able to solve systems of equations. All of you may not have had it, but I know my students had it, and a lot of the others that have come into the ILC have had it. So let's start with interpreting average rate of change. And anytime you're writing an interpretation for a rate of change, be it average or instantaneous, the first thing you want to address is, when is it valid? So you need an interval of time. When? Then what is changing? That's the output. So for our first example there, the output is the weight of the baby elephant. So when is it changing? What is changing? How is it changing? Is it increasing or decreasing? Then you have the arc, or whatever the rate of change is, and don't forget the units. So those are the important things to remember when interpreting a rate of change. So if we're given something like W of T is the weight of a baby elephant in pounds after T months, and we see that the average rate of change there, W of 12 minus W of 0 over 12 minus 0 is 85. So that tells us that our arc average rate of change is 85. When is this average rate of change valid? Well, during the first 12 months or during the first year of the elephant's life. What's changing? The weight of the baby elephant. Now, since we have a number here, we can tell that it is increasing. This baby elephant is gaining weight at a rate of 85 pounds per month. So the elephant's weight is increasing at a rate of 85. And never forget your units. Units of the output, so weight is in pounds, per units of the input. Input is time. So per month, not months. Easy enough? Okay, let's do the next one. V of T is the value of a car in dollars after T years, and I should have said T years after purchase, but I think you can figure out what I meant there. And we have that V of 4 minus V of 1 over 4 minus 1 is negative 1200. So to interpret that, when? So from year 1 to year 4, what is changing? The value of the car. Is it increasing or decreasing? How is it changing? It's decreasing. At a rate of $1,200 per month. Now, I don't put a minus sign here because I said decreasing here. And for my units, since it's dollars, I can use a dollar sign, but I do need to say per, and it's year, not months. So you don't have to put a minus sign and say decreasing. If you just say changing at a rate, then you would need to put the negative sign there. You've got to do something to indicate that it's decreasing. Okay, distance of a particle from its starting point in feet after t minutes. So we have that s of 60 minus f of s of 30 over 60 minus 30 is 4.5. So when is this true? During the second half hour. Or from 30 to 60 minutes, however you want to phrase that. What's changing? The distance of the particle from its starting point. How is it changing? Is it increasing or decreasing? Well, it's increasing at a rate of 4.5, and in this case, it is feet per minute. Now, if this were an instantaneous rate of change, like you're going to be learning about as derivatives, then this instantaneous rate of change could be referred to as velocity, because it would be 4.5 feet per minute as a velocity. But this is just an average rate of change. And then this last one, I was really trying to come up with something different. So I thought about the fact that as I drive to visit my daughter, the temperature starts to decrease. So capital T of X is the temperature outside in degrees Fahrenheit when I am X miles north of my house. So T of 300 minus T of 0. That means as I travel 300 miles north of my house, to see my daughter, the temperature is decreasing because it's a negative sign at a rate of 0.04. And this time for units, I'll just put degrees Fahrenheit per mile. Now with instantaneous rates of change, which is what you'll be interpreting in your calculus classes, if you were just given perhaps t primed of x, and let's put a number in there, t primed of 50. When I am 50 miles north of home, the temperature outside the car is changing, because looking at this, I don't know if it's positive or negative, at a rate of t primed of 50 degrees per mile. So it's the same format. It's just that instead of having an interval of time, like with average rates of change, you have just a specific moment in time. Questions? Okay. Let's move on to the difference quotient. We're going to start just by looking at f of x plus h, because a lot of students try to just take f of x and add h to the end of it. And that's not what it is. It's like a little composite function. You're taking f of x plus h. So we'll go through each of these. F of x is equal to 4x squared minus 3x plus 2. Then f of x plus h is equal to 4 times x plus h squared minus 3 times x plus h plus 2. So step number 1, you just replace x with x plus h. And then we simplify as much as we can. Now, maybe you've been doing these already and you have FOILed x plus h a few times. If not, come over to the side and do your first outer inner last. First times first gives me x squared, outers, inners, and last, and I've drawn my little happy man there. X squared plus 2xh's plus h squared. So it's always going to be this first term, the x squared, 2 times the first term times the last term, plus the last term squared. And I'm going to go ahead and distribute this 3 through the parentheses. And then I'll distribute that 4 through the parentheses. It's nothing hard, it's just tedious, and you need to be very careful with your parentheses. X equals 2 times, let's write f of x down first, x cubed plus 6x, and actually, I'm going to write on this one sideways because I know it's going to take up a lot of room. F of x is negative 2x cubed plus 6x. Now, maybe you don't know what x plus h cubed is off the top of your head, because we're going to plug in f of x plus h. We have negative 2. X plus h cubed plus 6 times x plus h. Well, I happen to have x plus h squared right here. So if I need x plus h cubed, I can just take this and multiply it by x plus h. So x squared times x squared times h, 2xh times x, 2xh times h squared times x, and h squared times h. Combining like terms, I have 1x squared h plus 2x squared h's, 2 xh squareds plus another xh squared plus h cubed. You can memorize the pattern, but if you forget it, you can always go back and recreate it. So we have 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed, and we've got a 6x plus a 6h. And now everybody inside that set of parentheses gets a 2. So, just a lot of algebra. Let's look at the next one. This one's really simple to plug in. F of x is equal to square root of x plus 6. Then f of x plus h is just the square root x plus h plus 6. Not a lot of simplifying to do, just that set of parentheses that's not really doing anything anyway. Similarly, our next one equals 3 over 2 x minus 1. Then f of x plus h and just a little bit of distributing. 2 times x plus 2h minus 1. Easy stuff. F of x, 2x over 3 minus x. I picked this one because it has a minus x to remind us to be careful with those signs. Everybody inside that set of parentheses is going to get a brand new sign. 2x plus 2h living on top of 3 minus x minus h. And I did not do an example that had a radical and a rational, and this morning they really wanted one, so we're going to make one up. We'll do f of x is equal to 2 on top of the square root of 3 minus x. So f of x plus h is equal to 2 over the square root of 3 minus x plus h, which is 2 over 3 minus x minus h. So we're kind of baby stepping our way to the difference quotient. We started just by plugging x plus h in. Now we're going to go on and do the whole difference quotient, because the reason we do the difference quotient is this is the average rate of change from x to x plus h, because we have f of x plus h minus f of x over x plus h minus x. Well, x minus x goes away, and this is your difference quotient. So we take the limit as h approaches 0, and that gives us our derivative. But right now we're just talking about simplifying that difference quotient. So let's start with the quadratic one. So, and I'm going to write it down and say it over and over again to help you get it stuck in your brain like glue. F of x plus h minus f of x, all of that over h. Well, I've already calculated f of x plus h. Yay me. X squared plus 8xh plus 4h squared minus 3x minus 3h plus 2. And yeah, I wrote too big. Let's get another marker, another board, and do it sideways. So this would be x squared plus 8xh plus 4h squared minus 3x minus 3h plus 2. And I'm going to subtract off f of x. All of that is living on top of h. So now all of that stuff is still hanging out. 4x squared and everybody in here needs to get a brand new sign. The negative 3x becomes plus 3x, and the plus 2 becomes minus 2, and all of that is still sitting on top of h. Now, I know when you're doing your homework, you're going to get tired of writing this stuff over and over and frickin' over again. So you could just come up here and change your signs. Minus 4x squared plus 3x minus 2. Just to remind yourself that everybody in there gets a new sign. Don't leave anybody out. Because 4x squared minus 4x squared goes away. Minus 3x plus 3x goes away. And 2 minus 2 goes away. It's magic. F of x has disappeared. If there is no magic, then you know that you did something wrong. And chances are what you did wrong was right here with the parentheses and the minus sign. So the magic should always happen. The f of x should disappear. And then everything left will have an h in it. The other tricky thing to be aware of is that everybody up top has to be divided by h. So you can think of it as factoring an h from that numerator. And then canceling. Or you can think about 8x over h gets to be divided by h. 4h squared over h gets to be divided by h. I forgot to factor them out there. 4 minus 3. There we go. Minus 3h gets to be divided by h. So just so long as everybody gets divided by h. That's another common mistake that students make. Questions? Okay. Let's do that cubic one. Pretty sure I wrote it sideways, so I'd have room. So again, f of x plus h minus f of x over h. Do my best to write small enough. I have 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed plus 6x plus 6h minus negative 2x cubed plus 6x. All of that divided by h. Now, I am going to be lazy this time because I just wrote all that big long thing out there. Everybody inside this little set of parentheses gets a brand new sign. So instead of minus 2x cubed, I have plus 2x cubed. Instead of plus 6x, I have minus 6x. So I just replaced that rather than having to write it all over again because I get tired. Now, magic. I have, and I lost a minus sign. I have minus 2x cubed plus 2x cubed. I have plus 6x minus 6x. So now I'm left with 6x squared h plus 6x h squared plus 2h cubed plus 6h, all of that sitting on top of h. So the magic happened. This entire f of x over here disappeared, just like I planned it. Everything left has an h in it. So this h goes away. That becomes just an h to the first power. This becomes an h squared, and that h goes away. So I'm left with just 6x squared plus 6xh to h squared plus 6. And now I have something that if I take the limit as x approaches 0, I can plug h equals 0 into and get a nice friendly answer. Questions so far? Oh, no, this was the next easiest one. The next one we have just a radical. X plus h minus f of x over h. So square root of x plus h plus 6, that's f of x plus h, minus square root of x plus 6, all of that over h. Now we need to simplify it because you all know what's happening. You know what's coming. You want to take the limit of this thing as h approaches 0. You can't do that right now or the world will explode. So let's multiply by the conjugate, just like we did when we were finding limits before. X plus 6. So this becomes a plus x plus 6, square root of x plus h plus 6, plus square root of x plus 6. Put parentheses around there. And now when I do first outer inner last, I know what's going to happen. My middle's going to fall out. I have first times first. So the square root times the square root means the square root disappears. Outers gives me plus this times that. Inners gives me minus this times that. So those disappear, and I'm left with negative times positive gives me minus square root of x plus 6 times square root of x plus 6 is x plus 6. All of that is over h times the conjugate. Now I'm going to go through and get rid of these parentheses. This set of parentheses isn't doing a darn thing, so it just disappears. Everybody inside this set of parentheses gets a brand new sign. You get a brand new sign, and you get a brand new sign. And the denominator stays the same because we don't mess with it until the very end. Now, this is when the magic happens here. Your numerator, everything in the numerator that does not have an h in it should disappear. X minus x plus 6 minus 6. Oh, look at that. All that's left up there is h. And I can cancel that h with that h, and I'm just left with 1 sitting on top. Square root of this plus the square root of that. Starting to feel comfortable with it now?
Yes.
Yay, I got an answer. Okay, let's do another one. I'm going to go ahead and go to the next row because I write big. So I have f of x plus h sitting here. Minus f of x. All of that on top of h. So now I have a difference of rational expressions on top of something. That's fractions over fractions, and that's just too much fractioning for anyone to deal with. So I multiply by least common denominator over least common denominator. Least common denominator has to have 2x plus 2h minus 1 in it to cancel away with that. It has to have 2x minus 1 in it to cancel away with that. And if I multiply on top, I have to multiply on bottom so that I haven't changed anything. I multiply this term by the least common denominator. 2x plus 2h minus 1 cancels. I multiply this term by the common denominator. 2x minus 1 cancels. And all of that is still sitting on top of h times the LCD. Now I need to distribute those 3's. So 6x minus 3 minus 6x minus 6h. Negative times a negative gives me plus 3 on top of that. Now we can start combining like terms. 6x goes away with 6x. Minus 3 goes away with positive 3. And then I look and I see that the magic has happened. The stuff on top is just a term with an h in it. I can cancel that h with that h, and I'm left with negative 6 sitting on top of the LCD. Questions? Okay, we'll make it a little harder. This one has an x on top and an x on the bottom, but we go through the exact same process. So 2x plus 2h over 3 minus x minus h minus 2x over 3 minus x is living on top of h. And again, I know that I'm going to have to take the limit as h approaches 0. I need to do some simplifying. And the easiest way to simplify a fraction on top of a fraction is to multiply by the least common denominator. So I multiplied this one times the least common denominator, 2x plus 2h times the 3 minus x that I'm left with. I multiplied this term by the least common denominator. 3 minus x cancels with 3 minus x. I multiplied 2x times the 3 minus x minus h that I'm left with. And now I have h times least common denominator. A little bit more complicated this time because I'm going to have to FOIL. First, outer, inner, last. Minus 2x times 3 gives me minus 6x. Minus 2x times minus x gives me plus 2x squared. Minus minus gives me plus 2xh. Almost wrote small enough to fit it. Need a clean board. So let's see, 6x minus 6x goes away. Minus 2x squared plus 2x squared goes away. Hey, this is looking good. I have a 6x left up here, and first, outer, inner, that should be a 6h. Y'all are supposed to stop me when I make mistakes. So now I'm left with, let's see, and I did have a plus 2xh here on the end. That was very messy and it was hard to read. So let's see, I'm left with 6h, h times 3 minus x minus h times 3 minus x. Cancel, cancel. So it's not hard, it's just really easy to make a mistake. I just proved that to you. So just be very careful with your algebra in these. Be careful when you're doing your multiplying, be careful when you're distributing those numbers through the parentheses. Got one more that has a radical and a rational. And I'm going to write down that difference quotient yet again, f of x plus h minus f of x over h, because by now you've probably memorized it whether you want to or not. We have 2 over square root of 3 minus x minus h minus 2 over the square root of 3 minus x. Now you have a big decision to make. You have this annoying radical and you have the annoying rational. Which do you do first? Take care of the rational first. So start by multiplying by least common denominator times least over least common denominator. So this one cancels with that one. I have 2 times the square root of 3 minus x minus 2. Now this one cancels with that one. So I have 3 minus x minus h. All of that is living on top of this times the least common denominator. So far, so good? Well, now I have a radical expression to get rid of. If you want, you could go ahead and factor that 2 out and just attach it at the end. I think I'll just leave it there. So I have 2 times the square root of 3 minus x minus 2 times the square root of 3 minus x minus h. And I'm going to multiply by 2 square root of 3 minus x plus 2 times the square root 3 minus x minus h. And that's over this least common denominator. So you're going to end up with the least common denominator and the conjugate down here. Conjugate works just like it always does. Yay for the conjugate. So 2 times the square root of 3 minus x, 2 times the square root of 3 minus x gives me 4 times 3 minus x. Outers and inners disappear. Last gives me minus 4 times 3 minus x minus h. And all of that is living on top of h times the LCD times the conjugate. Distribute 12 minus 4x minus 12 minus times minus is plus 4x minus times minus is plus 4h. And all of that is divided by h times this square root times that square root times the conjugate. Twelve minus 12 minus 4x plus 4x. I'm left with a 4h on top. I have an h down below, and if you're feeling fancy, you could factor this 2 out and bring it up there and put it with the h. Then you just have all these radicals left. You can cancel that h with that, and that 2 can go into that 4, and you're left with just a 2 sitting up top. Wouldn't you want to multiply by the conjugate first, then distribute? You mean when I pulled this 2 out? On the other slide, I multiplied by the denominator. Yes, I did that first. No, not that one. Find the right one. Oh, it's here behind. Right here. I went ahead and multiplied. It would have been easier to take out the radical first and then distribute. Let's see. So if we did 2 over square root of 3 minus x minus h, 2 over, actually, I'm going to write it again. Let's do it this way. 2 over 3 minus x minus h minus 2 over square root of 3 minus x. And then take out the radical first. So you want to do 2 over square root of 3 minus x minus h. Is that what you want me to do? Okay. So let's see, we would have first times first would give me 2 over, but then I'm going to have in the denominator, I'm going to have h, I'm going to have 2 over square root of 3 minus x minus h, and 2 over square root of 3 minus x down below. So then I'm going to have this times this gives me 2 over 3 minus x minus h. Outers and inners undo one another, and actually that should be a 4 because 2 times 2 is still 4. Minus 4 over 3 minus x over h times 2 over this one plus 2 over that one. Okay. And now we want to multiply by the least common denominator, and that would be 3 minus x minus h times 3 minus x, and 3 minus x minus h times 3 minus x. Okay. Things are working out. I have 4 over 3 minus x minus 4. The 3 minus x cancels. 3 minus x minus h. That's sitting on top of h times, when I multiply here, I'm left with the square root of 3 minus x minus h. So I have 2 times x minus 3 minus x minus h. I'm going to go ahead and just write it, plus 2 times on top of, yeah, I need the 3 minus x on top of the square root of 3 minus x minus h plus 2 times 3 minus x minus h times 3 minus x sitting on top of the square root of 3 minus x. Okay, so now in the numerator, I have the exact same numerator I ended up with a moment ago. 12 minus 4x minus 12 plus 4x minus h. Down below, I still have h. Here I have a square root of 3 minus x minus h on the bottom and a 3 minus x minus h on top. So that's the same thing as 2. times the square root of 3 minus x minus h times 3 minus x, plus over here, I have a square root of 3 minus x on the bottom and a 3 minus x on top. So that's the same as 2 times 3 minus x minus h times the square root of 3 minus x. Boop, 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 boop. And let's see, it looks like I lost an h. Did I? Yes, I lost an h there. I mean a 4. So now I have negative 4h sitting on top of, I could factor the 2 out just like I did. And I have the square root of 3 minus x minus h times 3 minus x plus 3 minus x minus h times square root of 3 minus x. And believe it or not, that's the same darn thing. You can do it whichever way you like better, and it's fine. Whichever way seems easier to you, because you are going to end up with the exact same thing. Yep. You've not done anything illegal either way that you do it. So you can do it either way that you want to. Okay, that one was pretty complicated. So if you can get through that one, you're doing great. Feeling a little better about those difference quotients now?
Yeah. A lot.
Good. Okay. And let's see. Oh, that's the one I just closed. Oh, I must have closed the wrong one. I wanted the one with systems of equations. There we go. Now I know that you learned to solve systems of equations in pre-calculus, and there are 2 ways that we generally do it. We do it by substitution and elimination. So let's just start with this first system we have here. 4x plus y equals 2. X minus y equals 3. And we're going to do it both ways, just for fun. So I'll start by substituting. And this one's pretty easy to do either way. Yeah, reminds you of middle school back in the good old days, doing the fun stuff. So let's start by getting x all by itself in this one. So x equals 3 plus y. Then I'm going to take this 3 plus y and replace the x in the first one. So I have 4 times 3 plus y equals 2. 12 plus 4y plus y equals 2. 4y plus y is 5y. Subtract 12 from each side. So y is negative 2. Then I can take this negative 2 and just plug it in right there and find out that x is equal to 3 minus 2, which is 1. Writing your answer as an ordered pair. I have 2 minus 1. What if I wanted to eliminate? Well, this is a really friendly system of equations because it's all ready for elimination as well. I have plus y, I have x minus y equals 3. So just add them together, 4x plus x, that goes away, is equal to 5. So x is equal to 1, and then 4x plus 1 is equal to 2. 4x equals 4 times 1 plus y equals 2. Then y equals -2. Next one, we have 4x plus 5y equals -12. 6x plus 5y equals 2. This one's not quite so friendly for substituting. So James, you're the only one left. Do you want to keep going? Or you feel pretty good about systems of equations?
I think I'm doing pretty good with systems of equations.
Okay. Do you have any questions on anything else?
I had I was doing WebAssign last night, and I think the one I have, all of them have practice and others. But there was one thing that I got confused on. Let me look if I can pull that up really quick.
Okay. I am going to turn the recording off because boot camps are all about the pre-calculus stuff. So I'll turn that off and then I'll help you with your WebAssign question.